Guys, I think we made a mistake in concluding that that noise in transient was not working. I'm going to show an example here where it does appear that it works just fine. In the conversation we had, we were missing two things. The first thing we were missing was that the analysis was giving us a warning telling us that a grounded capacitor was missing, and we were regrettably ignoring that. It was also the case that the word jitter should not appear in the transient analysis. So what I'm going to do here is I'm going to set up a little test again, and I'm going to add here a 250k resistor so that the noise is really bad. The jitter for this chain of 32 inverters is worse than it would be due to the presence of that extra resistor. So I think you can possibly see what I'm doing here. I'm doing the same trick as before. I'm connecting up 32 resistors in series like that, and we're going to add a power supply here and add a power supply here. And what we must remember to do is, in the transient analysis statement here, I'll run for only 50 nanoseconds. We simply put noise and we put frequency equals, and this is the low frequency corner that it will use, and freq h, the high frequency corner, let's say 100 meg. Right, that's all we need, no jitter statement. But we must also add a capacitor to all nodes, and Y needs a capacitor to ground. So and SmartSPICE did tell us that, we just didn't read the errors carefully enough. And I'm just going to add 10 femtos to ground, and that should be all that we need to do to make it a little easier. Save all voltages and the variance of the node Y. Alright, so I think this is going to get us going. Let me save this somewhere useful. Let me put it for now, I guess, into, and I'll move this to examples somewhere on Capella for you all to look at. Let's call this noise K, for want of a better word, test. Alright, so we've got noise K test there. So I'm going to connect to SmartSPICE now. Here we go, and we're going to hopefully run this simulation. So this is the latest version of Schematic 493, but actually this code has been there for many years, in fact. So an old version of the Schematic will do it. Okay, now we're up and running, and I believe that that is all we need to do. Let's find out if I've forgotten something else. Run. So this the guy's running now, and I don't think we got any. Oh, that was much too fast. That was much too fast. Let's see what we did wrong. Scrolling back inside here, what is it telling us is the mistake? Here it comes on the guitar here. Number of circuit equations. Okay, let me see what's going on. Warning, there are no. Oh, well, if that's to be believed, it's run already. Let's see if it's true. Plot K of Y. Yeah, there's something going on there. It looks like it's not sure I entirely buy the. Oh, I didn't apply any input signal. Good heavens, Martin. VA between A and ground, 0 volts, a pulse from 0 to DVCC, delay, rise, fall, period, repetition time. Right, that's more like it. Let's try that again. Here we go. Right, well, it's something cooking. Let's see how we're doing. Go look at SmartSPICE. Yes, it's running. I'm going to plot this A signal, make sure that looks, yeah, there's A going up and down. We're at 10 nanoseconds. Let's plot the variance of the output signal. Yeah, that's more like it. Now there's some, event occurring at some time, and that will correspond, no doubt, to the voltage change on the Y output. Yeah, there it is. Look, that pulse of variance corresponds to that point there. There you can see now it's going to work. I'm going to remove that raw file and add it again, and it should show me the time. Come on. Well, there we go. 46, almost done. When it finishes, it shows us the table of capacitances. Now we should be able to do this. Plot the voltage on the Y node. There it is. And if we zoom in on this guy, we can see that there is a non-infinite transition time. So there we go. And if you want to know how wide that is, just drop a marker on it. That is 56 picoseconds wide. So you see the methodology is working. So to be clear, you do not put the jitter statement into there. You simply put noise. You must specify the low frequency corner that it uses for 1/f and the high frequency corner. And then you must add, make sure there's a capacitance on every node to ground. Y didn't have one. All these nodes in between did have one, no problem, but Y didn't. So there you go. I hope this helps.